Let us look at this particular problem. Here we have a tank which is filled with fuel or an oil or some liquid of density 700 kilogram per meter cube. The height or the length or the height to which it is filled is 10 meter, and the diameter of the tank is given to be 2 meter. Yeah, so draw the pressure diagrams for the sides. Okay, so we have been asked to draw the pressure diagram or the pressure prism as they call it. Yeah, pressure diagrams are also called as pressure prisms. For the sides, indicate the minimum and maximum pressure. Okay, that's fine, we can do that. Calculate the pressure and force at the bottom of the tank. So they are asking us to calculate what would be the pressure and the force over here. I have already drawn the pressure prism for you guys for the sides, but what I will do is I will draw it again for you all. Is that okay? So what do we have? So this is the gauge pressure diagram. Yeah, pressure prism. So this is the surface of the fuel. So the minimum pressure is going to be at the surface, which is P minimum equals 0. Yeah, and then what is going to happen? The pressure is going to increase. The length of the arrows indicate the amount of pressure. Yeah, it is going to be very high. So if I draw, it's going to be like this. Yeah, if I, and this is going to be at the end, is going to be the P maximum. Yeah, and if I have to draw the pressure diagram for the other side again, this is going to be P minimum equals 0, and it is going to go like this. Yeah, this is the gauge pressure diagram. And I also wanted to draw the absolute pressure diagram for you guys because it's quite important that you know. Yeah, if this is the tank and this is the level of the liquid, we already have absolute pressure. Do you remember? I told you all about GPAP. Yeah, so what is this? Absolute pressure equals gauge pressure plus atmospheric pressure. Yeah, so even though the gauge pressure at this point at the top is 0, there is an atmospheric pressure of 1 bar, is there not? So let us begin here. If this is 1 bar, and then the pressure prism will go like this. Yeah, yes or no? The absolute pressure is going to keep increasing. Yeah, P min, this is P min, this would be P max. Yeah, pressure max. Similarly over here as well, this line indicates the uh, P min, which is going to be 1 bar, 1 atmospheric pressure, and then it's just going to go like this. There you go. Yeah, this would be the absolute pressure diagram. Yeah, so now we have to find what is the pressure at the bottom and the force that is exerted at the bottom because of this liquid, because as you know, all this liquid over here in the tank is going to be exerting a force down. Yeah, so we've got to find the pressure and that force. So the pressure equation is rho g h, the density times gravity times the height from the top. Yeah, so which would be density is 700, the gravity value we already know, and the height is 10 meter. If we put it all in the equation, we get the pressure at the bottom to be 66.67 kilopascals. Yeah, now how to find the force, my dear people? Force is nothing but pressure times the area. Yeah. So what do we know? the pressure value is given, and the diameter we know is 2 meter. So pi d square divided by 4. So we just have to substitute everything in the equation, put it in the calculator, and then we get the force at the bottom to be 215.7 kilo Newton. That's it.